Hello everyone. Today we are starting the second chapter of our module first, which is chapter number 1.2, single phase supply from grid to household. In this chapter, we'll be looking at how the power is transferred from my generating point to my house socket or the appliance. How the power is transferred, what are the different steps involved. So let us see one diagram. The first part is from my generating point, which is this, to my last, which is this electrical mains at my house. So from generating point, which is at starting point 1, to my house mains, the power is transferred via a series of substations. We can see these two are substations. This one is the step up substation. Okay, this is the step down substation. In between we have this transmission line. Okay, now the question arises, what is the meaning of step up and step down is basically related to the voltages. Whenever the voltage level is up, we call it as step up. When the voltage level is down, we call it as step down. Now with the help of the transformer action, we do this step up and step down. But the more important question is, why do I need to step up or step down my voltages? Now, for our household, requirement, the voltage level requirement are 230 volts for the single phase, or in some special cases, in the industry or the commercial building, we may need the voltages in the range of 400 to 500 volts. So standard wise, 415 is in the IEC standard for three phase, and 480 is in our NEC standard. Now, these are the voltage level requirement for the single phase. Okay, these are the single phase voltage requirements. So naturally, I need to step down my voltages to meet these levels. Now, why do I need to step up? Because my transmission happens at a higher voltages like 110 kV or 230 kV. This is not the voltage at which my generating station is generating the power. It is generating at the voltages like 415 volt or 11 kV. Okay, these are general the voltages. Now, the answer for the question that why do I need to step up is from this power equation, that we know the power is equal to voltage multiplied by current. Now, naturally, for the same power generated, if I am increasing the voltage, the current will automatically decrease. And we know the voltage drop, or I would say losses, are somewhat proportional to square of my current. So if my current is decreasing, then my drops or the losses will automatically decrease. So from the operational efficiency perspective, my voltage levels are step up during the transmission so that my current in the transmission decreases, and the losses and drops also reduces. So in this part, we have seen that how my power is transferred from the generation point to my house mains. Now the next part is how the power is transferred from my mains, which is this, okay, which we have seen earlier. Okay, the fifth number point, to my appliances. These are my appliances. Okay, or this is my sockets. So the different parts for the different components involved in smarts are this. Fifth one is my electrical mains. Then it is goes to the electrical meter, the power measurement device, which is used for the billing purposes. Then the power is go to my main MCB. Okay, then it is goes to a residual current device, which is used to protect from the leakages of current. Then it is goes to my MCB, which are the circuit breakers required required. We have obtained their selection and sizes from my circuit distribution, and then it reaches to my sockets, okay, or my appliances. If you're not getting about this part, do not worry. I will be explaining in my next module in quite detail that what is this main MCB, what is this residual current devices, what are this MCBs, the individual circuit breakers for the area of the house or individual appliances, how they are selected and how they are sized. This we will be looking in my next module in quite detail. So for the sake of to know that how the power is reaching, there are steps in order from first to point number 9. So our scope of this course is from fifth step, which is from electrical mains to to our socket or to our appliances, is what the scope of this course, to learning how this whole planning and how this whole electrification for any household is done. This is what our scope of this course work is. So this is it. Thank you everyone for your time and attention. The next chapter we'll be looking in the same module 1 will be chapter number 1.3, which is related to the different units we see in our household. Like the voltages, VI, watt, kilowatt, and kilowatt hour. We'll be looking what are these units are, what they represent, what are their uses. Okay, everything will be looking in our next chapter. Till then, thank you everyone.